photosynthesis, right? Photosynthesis takes light and CO2 and makes organic matter. And that happens in the surface of the ocean. Well, when they breathe in all that CO2 and make it into organic matter, how much CO2 in the ocean goes down, right? They're sucking it out of the top of the ocean. So more dissolves in. This is what we call our pump. So we're pumping CO2 into the ocean. Well, it doesn't just go into this surface layer. That's where all the action is. That's where the photosynthesis is. Remember the part about the compost? So they're photosynthesizing, they're living, they're getting eaten. These guys are dying and falling down to the bottom of the ocean. And this is like a giant compost bin. It's yeah, so as it pulls it in and it goes out the bottom. Now, a couple things I need to point out here before I go on. This is the surface ocean. It sits like a cap on the whole ocean because that's where it's warm and it's light. And it's a very, very thin layer. This figure is a little bit deceiving because if you look at this, it's got two different scales. This all happens, this whole photosynthetic process happens in the top 100 meters of the ocean. That's about 300 feet deep. Down here, it's 3,700 meters. There's 4,000 meters, 2 miles of ocean, which is your compost bin, okay? So we've got this pump pulling all this CO2 out of the atmosphere and putting it into the bottom layer. And this thin, thin layer, it's warm, it's somewhat impenetrable, and it acts like the cap on the soda bottle, okay? This is the surface ocean, and this is the deep ocean, okay? This is, all that CO2 is trapped down here in the deep ocean because as it goes down, the only thing that can live down there are animals. They eat the organic matter, they breathe it out as CO2. So the whole ocean is like a bottle of soda with the cap on. Now, if you've seen pictures of the deep ocean, there's a lot of CO2 down there in the deep ocean because there are organisms that can live and eat it. It's not quite a compost bin. If it was a compost bin, it would be stinky and disgusting. And one of the reasons the deep ocean is not stinky and disgusting is because of ocean circulation. What happens is that deep ocean is renewed quite regularly. And it starts with the surface ocean. The wind blows, and it forms a surface current. Here's our very famous Gulf Stream. All this warm, salty water goes to the poles, and it gets quick chilled, and it sinks. Because if you make water cold, it gets more dense, and it sinks to the bottom of the ocean. And then it travels around. We call this the deep conveyor belt. So warm surface water starts here with not very much CO2, because all those organisms sucked it out. And it goes down, and it travels around the bottom of the ocean like a garbage truck, picking up garbage and CO2 all along the way, and it kind of rises in the Pacific Ocean. And we can see that. I'm going to slice the ocean open for you here, and I'm going to stand on South America, and I'm going to look this way, and what you see is, here's the south, there's the north. I'm standing in the ocean on South America, I'm looking across the Pacific Ocean, and you can see that conveyor belt coming up. The redder it is, the more CO2. So as this water travels up the Pacific Ocean, it's getting more and more and more carbon dioxide in it. The other thing you can see in this figure is here's my surface cap, right? And that's the atmosphere concentration, and there it is up in the surface ocean, and that's the cap. Keeps it in, okay? And it's hard to get back out. It does come back out, but it's hard to get it out because this serves as a cap. All right, that's the real data. This is probably easier to visualize. Here's the atmosphere. It has about, the ocean is definitely the elephant in the room when it comes to CO2. We've got 70 gigatons. One elephant is 70 gigatons, believe me. Okay, in the atmosphere. That's balanced by about the same amount of CO2 in the surface ocean, above the cap. And then that pump pumps all that into the deep ocean, and it's holding 50 times as much. There's about 400 gigatons of carbon dioxide in the deep ocean. And this is a bit more to scale. That layer is very, very thin, remember? This layer is very, very deep. That last figure showed you how thin that surface cap